Good afternoon, ladies and gentlemen, distinguished guests, and our esteemed speaker. A warm welcome to all of you. This is Dr. Beena Gandhi Deori, Deputy Director Research, SAARC Cultural Center, Sri Lanka. It gives me great pleasure to welcome you all to the 8th SAARC Talk series. This lecture is special because this is the last SAARC Talk series of the year 2023. Before we start with this special lecture, I'd like to invite Mrs. Renuka Ikanaike, Director, SAARC Cultural Center, to deliver the welcome address. Madam, over to you.
Thank you, Bina. Good afternoon. Dr. Sanath Panawennage, distinguished guest, a very warm welcome to the 8th session of the talk series on cultural heritage
Now
and
off.
cultural diversity in the SAARC region, hosted by the SAARC Cultural Center.
Mic has some problem.
I am honored to welcome you as the director of the SAARC Cultural Center and extend my heartfelt greetings to each and every one of you. The primary objective of this talk series is to foster a deeper understanding of cultural heritage, diversity, and inclusion in the SAARC region. We believe that by discussing these aspects, we can contribute significantly to the sustainable development of our nations and strengthen the ties that bind us together. Today, we are privileged to have with us a distinguished speaker, Dr. Sanath Panawennage, the Director General and Chief Executive of the Arthur C. Clarke Institute for Modern Technologies. Dr. Panawennage brings a wealth of knowledge and expertise to the table, and he will be sharing his insights on the crucial topic of preserving South Asia's cultural heritage, space as a decisive enabler. We are immensely grateful to him for dedicating his time and expertise to enlighten us on this significant subject. The preservation of our cultural heritage is not merely a matter of historical importance, it is a key to our identity, a bridge to our past, and a foundation for our future. Dr. Panawennaga's exploration of how space can be a decisive enabler in this endeavor is both timely and relevant. As we navigate the challenges of the modern world, understanding the role of space in preserving our cultural heritage becomes increasingly crucial. I extend my sincere thanks to each one of you for gracing us with your presence today. Your participation in this talk series reflects your commitment to the importance of cultural heritage and diversity. I encourage you all to actively engage in today's session, ask questions, and share your thoughts. Your collective wisdom and insights are integral to the success of these discussions. Let us make the most of this opportunity to learn from each other, to deepen our understanding, and to forge connections that transcend borders. I hope that this talk series will serve as a valuable resource for all of you, contributing to the collective knowledge that will shape the cultural landscape of our region. Once again, thank you for being here, and I wish you an enriching and insightful experience during today's session. Thank you.
Thank you, Madam, for your welcome address. Ladies and gentlemen, we have amongst us engineer Dr. Sanath Panawennage, who is a chartered engineer specialized in electronic and telecommunication engineering. He has a PhD in space policy and a fellow of the Institution of Engineers, Sri Lanka. Since June 2008, he has been functioning as the Director General and Chief Executive of the Arthur C. Clarke Institute for Modern Technologies, a public research institute which also functions as Sri Lanka's national agency for capacity development in space technologies and applications and international coordination in outer space affairs. His research interests mainly include radio wave propagation modeling, space technology, and space policy. Dr. Panawennage is credited as the founder of Sri Lanka's Program for Acquisition and Development of National Capacity in Space Technologies, having conceptualized and launched this program with design, development, construction, testing, launching, and in-orbit operation of nanosatellites in technology, collaboration with leading spacefaring nations as the key strategy. He has been leading the program to date, also functioning as the principal investigator and project director on the Sri Lankan side of all three satellite development projects undertaken under the program, commencing with the country's first ever nanosatellite Ravana 1 launched in 2019. Dr. Panawennage has also been elected to and served in multiple leaderships in international intergovernmental platform for cooperation in space application in the Asia Pacific region, including as the chairman of the 35 Nation Intergovernmental Consultative Committee on the regional space applications programs of the United Nations Economic and Social Commission for Asia and the Pacific for five sessions since 2010 to 11. And this afternoon, we have Dr. Sanath is with us, who is going to speak on a very pertinent topic, that is preserving South Asia's cultural heritage, space as a decisive enabler. So I kindly request Dr. Sanath to start with his presentation.
Hi, Boan. Good afternoon. Thank you very much for your kind introduction. It is indeed a pleasure and privilege for me to be here uh, delivering this talk on preserving South Asia's cultural heritage, space as an decisive enabler. Um, I'm very thankful to the invitation that was extended to me to deliver this talk by uh, Madam Director, Mrs. Renuka Ekanaika, and the SAARC Cultural Center. This is our title, Preserving South Asia's Cultural Heritage, Space as a Decisive Enabler. Well, as you are all aware, South Asia is a hotspot of cultural diversity. Not only is it a hotspot of cultural diversity, for the same reason, it is also the hotspot of cultural heritage. And that results in, when it comes to the concept of cultural heritage, there is a multi-dimensional, multi-aspect uh, construct. But in this particular talk, we will be probably, as may be seen from the picture I have used in this profile slide, um, we'll be using, we'll be concentrating pretty much on one aspect of that cultural heritage, which particularly lends itself for being examined using the kind of technology that we are going to talk about, that is space technology. Space technology has a lot to offer when it comes to preservation and management of cultural heritage, particularly the archaeological dimension of cultural heritage, as you would see during the course of this presentation. Some facts about South Asia's cultural heritage. UNESCO has designated 65 World Heritage Sites in 6 countries of Southern Asia. So, Afghanistan, India, Nepal, Pakistan, Sri Lanka, and Bangladesh. Uh, so these 65 sites are only a tiny fraction of the total number of cultural heritage sites, as we all in South Asia are aware. In fact, the countries that have not been listed, the South Asian countries that have not been listed in this list, do have their rich cultural heritage and many cultural heritage sites the only reason why it is not appearing here is the fact that they have not been designated in this UNESCO 65 UNESCO's cultural heritage sites. Of course, this designation process, everybody knows, is a quite complex, lengthy process. So we are this number is bound to increase as more and more sites are being designated or in UNESCO parlance inscribed as UNESCO cultural heritage sites. Um, so this gives some picture about uh, South Asia's comparison with the rest of the region or some other regions in terms of cultural heritage site intensity. But in this case, what have been taken into account are the sites that have been uh, designated by UNESCO. So you can see that South Asia um, uh, is remarkably high in terms of the density of cultural heritage sites compared to some of the other parts of the world. So it has cultural heritage sites beginning from the ancient civilizations of Mohenjo-daro and Harappa to various historical kingdoms across the region. So looking at Sri Lanka's own um, contribution to the vast cultural heritage of the South Asian region. Sri Lanka, being an island of just 65,610 square kilometers, within this 65,000 square kilometers, there is an estimated 250,000 archaeological sites. So that's an amazing number. Not all these sites have been identified so far, but this is a very probable estimate that have been made on the basis of the sites that have been identified from different uh, regions of the country. Um, so taking an average, I mean, um, it's an estimate that has been made on the basis of the number of sites that have been identified from various sample areas all over the country. So these are so Sri Lanka has a total of six cultural uh, UNESCO designated cultural heritage sites, starting from our ancient kingdom at Anuradhapura, so which endured uh, for 14 centuries as the capital of Sri Lanka. Uh, Many believe it as the most enduring kingdom in the history of the world, which has endured for 14 centuries from the 4th century BC to uh, 10th century CE. And so then followed by Polonnaruwa, the second kingdom of Sri Lanka. Then there are two other uh, uh, cultural heritage sites UNESCO designated. One is Sigiriya, once again the 5th century, and then Dambulla, once again belonging to Anuradhapura era, and then the other site is Kandy, uh, and the last one is Gaul, which has been inscribed as a cultural heritage site, mainly for its rich cultural heritage from the colonial era. So some this slide shows some cultural heritage sites within the city of Anuradhapura. So Jethabana Stupa, this third century stupa, was the tallest brick structure of the ancient world. So this was built in the third century CE, and it was 121.9 meters. In other words, 400 feet tall. So that is the highest, the tallest brick structure of the ancient world. And then we have Sigiriya, the rock citadel, the rock kingdom that was built in the 5th century. Well, then we have this other site that is shown as an example, the uh, the structure called Lower Mahapai or the Brazen Palace, which is second century BC structure, and that was the tallest building of the ancient world, a nine-storied building, and we can still see the remnants of that. And then uh, ancient irrigation systems of Sri Lanka, beginning from 4th century BC, based on unparalleled use of very advanced irrigation engineering, hydraulic engineering technologies are outstanding. Actually, these are the concepts like sluice gate, which have been built using stones at that time. This idea of sluice gates, a great idea, a very important concept in hydraulic engineering, was not to be seen in other parts of the world uh, for the next many centuries that followed. So this is Sri Lanka's contribution to the rich cultural heritage, part of Sri Lanka's contribution to the rich cultural heritage of South Asia. And our cultural heritage is endangered by many factors, both natural and artificial. So there are impacts of flooding and impacts of natural disasters like earthquakes. And there is erosion that happens over many years. And one of the other threats to cultural heritage is air pollution, so which has become a significant uh, factor impacting cultural heritage sites uh, of late. And then one of the problems is, unfortunately, these are man-made causes, looting, which poses a huge threat to those cultural heritage sites. And urban sprawling has its own impact on cultural heritage. So there are many instances where rapid urbanization, mostly messy urbanization, unplanned urbanization, sometimes having a huge impact on cultural heritage. So what is it that we can do by using space technology to preserve cultural heritage? So uh, how are we going to use the vantage point of space to discover and preserve our cultural heritage? So this is the monitoring cultural heritage from space is something, perhaps its roots in monitoring some of these sites from by the use of aerial photography. Observing heritage sites from above uh, for preservation purposes has a long history, of course. In early 1920s, scientists were using aerial photographs to map archaeological sites. Um, in 1972, uh, so World Heritage Convention was adopted by UNESCO's General Conference, and coincidentally, in the same year, remote sensing of Earth by civilian observation satellites also began on a regular basis. So, as the civilian Earth observation satellites came into existence on a regular basis, it happened incidentally in the same year that World Heritage Convention was adopted by UNESCO's General Conference. So we had the uh, access to this tool right from the inception. The question is to what extent we have been successful in adopting that tool for uh, effective in an effective and efficient way in managing and preserving our cultural heritage. So viewing cultural heritage from above using aerial photography. Uh, so that was in evolution uh, up to the use of satellite imagery for cultural heritage. Before the days of satellites, people used aerial photography using various techniques. And in the very old days, I mean, they just used cameras tied to pigeons to take aerial photographs. I mean, various types of aerial photographs, and mapping or photographing some of the cultural heritage sites was something that was uh, done. So similarly, I mean, cameras on board balloons and cameras on board aircrafts were also used for this purpose. So this is an example of such an aerial photograph. before the days of satellites, and that was from Odisha, from Sisupalgat from Odisha. This was taken in 1948. This was roughly 9 years before the first satellite, first ever man-made artificial satellite, Sputnik 1 of the Soviet Union, was launched into space. Sputnik 1 was in 1957, and this is 1948. And so this is an example of what the satellites can offer. Actually, these two satellites that are pictured in this picture are two satellites from the German space agency, which is called DLR. These two satellites are radar satellites that I mean they're called Terra SAR and Tandem are the two satellites. These two satellites are moving uh, about 400 meters spacing in between them, and by using that. So this was this pair of satellites belonging to the German Space Agency um, uh, is an example of a classic example of what we call synthetic aperture radar satellites that can be used for monitoring a lot of things. I mean, amongst the many applications, monitoring of archaeological sites is it offers a great potential for that. So it can monitor flooding, degradation, urbanization, and air pollution. So so this actually lists the space-borne technologies, the space-derived technology tools, and the other technology tools that can be used in integration with such technologies uh, for this purpose. So uh, we have Earth observation satellites, optical and SAR. The purpose of an Earth observation satellite is to observe the Earth, as the name implies. So the technique is called remote sensing. So its task is to observe various properties on the Earth. When you say various properties, it can be physical properties, uh, geometric properties and biological properties and so forth and so on. So it can observe those properties using electromagnetic radiation as the mode of interaction. So this happens um, in basically two broad categories. There are two broad categories of Earth observation satellites. One category is called optical Earth observation satellites, and the other category is called synthetic aperture radar, or in short, radar satellites. But we don't have to go into great technical details of those things. In optical satellites, it's very simple. What we are using is the light that is reflected, the visible light, the light that is visible to the human eye, that is reflected from uh, the surface of the earth, and also some other uh, bands which are not visible, like infrared radiation. And in synthetic aperture radar satellites, the technique is a bit different. There, the satellite itself emits a signal down to the earth um, in order for those signals which are getting reflected from uh, various uh, uh, parts of the surface of the earth are collected once again, received once again by some sensors on board the satellite to determine those physical, biological, geometric, and various other properties. So together with that, another technology that can be combined with this, particularly for archaeological sites, is what is called ground penetrating radars. So the idea is simple. Satellites are not capable of penetrating ground other than up to a distance of several centimeters, a few tens of centimeters, I would say. And so there we need to combine this with another technology called ground penetrating radars. Then we have another technology called light detection and ranging, LiDAR, which is same as radar, but in this case, the signal that is being sent is a light signal. And then global, or in other words, a laser signal. And then Global navigation satellite systems are basically satellite systems that are used for precise uh, determining precise time on any point of the earth and precise position on any point of the earth and for navigation purposes. And actually in this case our application is mostly determining the precise point on the surface of the earth. So then unmanned aerial vehicles, drones, various sensors that are on board unmanned aerial vehicles can be used in a very effective way. Then combined with those technologies, nowadays there are uh, artificial intelligence related technologies and then some related technologies like machine learning and deep learning, which make up this ensemble of technologies that can offer a great potential in the preservation uh, and management of cultural heritage. And this is an example of a satellite image. This image has been made in 2012 um, in the capturing Brahmaputra River, some part of that, and this area was inundated. And the satellite picture, the two satellite pictures show the situation before and after the inundation. There was a plenty of there was a plenty of archaeological sites that got inundated during this flood. So those satellite imagery were immensely useful in assessing assessing the impact and then taking some recovery measures. And then this is an example of using what is called spaceborne um, synthetic aperture radar for deformation mapping. There can be deformations that can undergo due to various reasons. One of the This is actually, I will skip this technical description. So and I will straight away jump onto application. So this is how uh, the deformations that happened in many archaeological structures in Nepal was measured using synthetic aperture radar during the 2015 disastrous earthquake in Nepal. So spaceborne synthetic aperture radar, which means synthetic aperture radar systems that were used on board satellites, were immensely helpful in assessing that damage, particularly in this particular aspect in deformation mapping, because structures can undergo huge deformations as a result of earthquake that we know. And so satellites offer a huge advantage in mapping such uh, deformations. And then another area is land subsidence. So land subsidence also is an area where uh, radar satellites or synthetic aperture radar satellites can be very effective. So now when you look at these pictures, actually this is uh, these two pictures are from Rome, and picture A shows the imagery, and then picture B shows actually land subsidence. Of course, you can see most of the areas are green. That means the subsidence of land has been um, about 1.9 to 2 millimeters per year. In the yellow areas, it has been from 4.9 to 2 millimeters. And you can also see some red spots where it is more than 5 millimeters per year. For 5 millimeters per year, of course, is a subsidence that the naked eye can never detect. So most of our other observation techniques will not be able to precisely measure that kind of subsidence. So if there are any warning signs like that, so synthetic aperture radar provides a very effective, very accurate tool for measuring that kind of subsidence. So it can be measured over the years, and some preventive action can be taken to ensure that there are no harmful effects to our archaeological monuments as a result of land subsidence. So, very effective tool. Perhaps this cannot be done uh, uh, with this kind of effectiveness with any other technology. And air pollution, of course, is another area of concern. Air pollution is an area of big concern to natural heritage. Of course, there are natural heritage sites. The figure that you see on top right hand corner is Sri Maha Bodhi tree, uh, a branch of the tree under which Lord Buddha attained enlightenment 2,500 years ago. And this branch was taken to Sri Lanka by uh, uh, Arhant Sanghamitta in the 3rd century BC. And this was planted in the sacred city of Anuradhapura. And this tree is still there as the uh, as the oldest tree in historical records in the whole world. So, and the tree actually is susceptible uh, to air pollution. So this is a great area. I mean, this is a very important area where only air pollution monitoring can be really helpful in preserving our cultural heritage. The other side that I have shown is, of course, the world famous Taj Mahal. This monument is also susceptible, pretty much susceptible to air pollution. And of course, a lot of actions have been taken, as many of you may have seen, in the form of banning vehicle emissions in the surrounding area. So if you go to Taj Mahal, you have to take an electric vehicle to get there. I mean, this was a practice for the last so many years. So air pollution has a significant impact on many archaeological monuments. So, and the satellites offer the most effective tool for air pollution monitoring, and therefore this can be a this is a very cost-effective and efficient tool for air pollution monitoring uh, uh, from the perspective of its impact on um, archaeological sites. And LiDAR technology that I mentioned a couple of slides ago is a very important technology. Here, what we do is we actually uh, emit a laser beam towards the ground, and it is getting reflected from different levels of the ground. You can see when it is uh, emitted from a laser source, and it laser scanner. It goes so it gets reflected from various levels. For example, it gets reflected from uh, the crown, that is the canopy level. It uh, reflected from the it is getting reflected from the levels below, right up to the ground level. So from the figure here on the left hand side, you can see these reflections from different levels. This reflection is coming from this level, and this reflection from this level, and this reflection finally from the ground level. So that is the advantage of this. And the advantage of this technology is actually there are some sites which cannot be seen from optical satellites, and sometimes even what we call radar satellites cannot penetrate vegetation canopy. In such situations, actually, you can see this using LiDAR technology. You can see these sites as if there was no uh, forest cover, there was no tree cover on top of that. Basically, what you are doing is you are effectively removing the tree cover, removing the vegetation cover on top of this surface, and seeing the surface as if there was no vegetation cover, as if there was no tree cover. So those LiDAR sensors can be mounted either on satellites or on drones. So both are used, spaceborne lidars, and then airborne lidars are the two technical terms used for that. And this is an example of how lidar imagery has been used to locate some ancient features like roads and buildings, from the Mayan civilization. This is from Mexico. Actually, this area doesn't look like this. This area definitely is, I mean, has a lot of trees and a lot of forest cover. But using LiDAR sensors, archaeologists have been able to remove the effect of that forest cover and see what exactly are there uh, below the surface. And Sigiriya, of course, the western side of Sigiriya has, the western flank has not been excavated, so it has not been much exploration work has not been carried out on this side. So LiDAR offers a very effective tool for this, because you can see beneath the tree cover and you can see what is there under the sea cover, and then identify various structural forms when you get rid of the effect of the tree cover. And then uh, another type of application is what you call global navigation satellite systems. Uh, Global navigation satellite systems, as I briefly mentioned earlier on, the purpose is to identify the precise position on any point on the surface of the Earth. And then timing and navigation is also there, but that's not very relevant to this application. So you can precisely identify the position. So here we see an example of a GNSS sensor that is mounted on the surface of the Earth. By tracking the signals from global navigation satellite systems satellites, uh, so we can uh, identify any minute movement, any minute shifting of the surface of the Earth. Uh, Thereby, we can we can know in advance whether there is any likelihood of any surface shifting. If there is any pattern, then of course precautionary actions can be taken much in advance before that kind of shifting of the Earth can do any damage to any archaeological site or a monument. So in most cases, in many cases, actually, it's not just one technique that is being used. So we have to use a range of technologies. Now, this is an example of
Ask
use
questions. No,
of
ask questions.
aerial photography, global navigation satellite systems, and LiDAR, all three technologies for 3D modeling of some archaeological sites. This was carried out in Sri Lanka. In fact, I must give credit to this project called Zamani project. They have done this in many places in the world. So in Sri Lanka also they have done this in a couple of sites. So this is from them, uh, courtesy Samani project. And so these are some sites from Polonnaruwa. So once again, what is called Lanka Tilaka Vihare of Polonnaruwa, that is on the left hand side, and on the right hand side, an image of Girivehera, which has been modeled as a 3D model using those three technologies: LiDAR, uh, uh, satellite imagery, and airborne uh, remote sensing. And these are some other pictures of those two sites from Polonnaruwa. What is on the left hand side is what is called Kirivihara, and then on the right hand side, Galvihare, uh, rock temple, uh, carvings. Actually, this slide is a 3D animation of what these 3D models can do. So they can be used to facilitate, enable the viewer to have a full view of this in 3D. So I'll play this. Uh, so this is Polonaru Watadage, and the viewer can see this from any angle. So an extension of this can be made by incorporating the technology domain called virtual geographic reality, where you can not only see in 3D mod, but you can also uh, move into the structure as if you are moving into the structure, and go into various places within the picture and get the viewpoint as if you have visited that center, visited that place uh, inside this site, and then you can get the view as if you are there, as if you would see in various directions when you enter that place. So that's an extension of this technology. So uh, then, in addition to those technologies, actually, we have been looking at the use of various satellite based technologies, remote sensing satellites, remote sensing satellites, synthetic aperture radar satellites, and then LiDAR technologies, uh, and then various other technologies like GNSS, Global Navigation Satellite Systems, which are all referred to as space technologies, which can come handy when it comes to monitoring of archaeological sites and preservation of archaeological sites and overall management of those sites. And actually, those technologies are hugely leveraged by the potential of artificial intelligence. So AI is an area that everybody is interested in these days. Of course, AI was there as a technology for uh, very many years, but over the past few years, the emphasis on AI has uh, taken a great stride because the vast potential that it offers for various types of applications. When it comes to use of satellite imagery with harnessing the power of artificial intelligence, of course, it has come to a situation where it can deliver wonders. So, thanks to the huge availability of high resolution images provided by satellites, planes, and drones, there is less need for archaeologists to make visits to in situ sites like in the early stages. So, while examining thousands of images can be a hard task for humans, artificial intelligence algorithms can scan quickly a vast amount of data to identify potential areas of interest. So this is a huge area, and let's see
Decisive.
what it means and what are the latest developments. When it comes to uh, um, observing uh, Earth using satellite imagery, of course, we refer to all these technologies that are available to us. And what we are effectively doing is, I mean, from a conceptual standpoint, what we are effectively doing is we are transforming this natural Earth to digital Earth, from natural Earth to Earth that you can see in your computer, from natural from the properties of the natural Earth, from the properties of the Earth that you physically see, to the properties that you can deal with on top of your computer, process in your computer. So this is the transformation that we do by using this satellite imagery and then using various technologies. Of course, nowadays we talk about big data, and when it comes to Earth observation, we talk about big Earth data. That is various layers of data that is incorporated in digital form. So this data is some of this data is space derived, meaning they are derived using uh, various remote sensing satellites and other forms of satellites and other forms of airborne sensors like LiDAR and various other drone based technologies. So the vast amounts of data that are so developed then then they can be used to create this digital earth by incorporating some digital technologies, including artificial intelligence, very importantly. However, something that needs to be particularly paid attention to is the fact that over the past 1 year, one branch of artificial intelligence has come in very handy. We're all aware that it was only last November that we heard for the first time about this now very famous application called Chat GPT. So uh, so many millions of users are using chat gpt, hundreds of millions of users are using chat gpt. I mean, that has happened over a period of just 1 year. Nobody knew about this last October 2022 October. There was no such thing, but now everybody is talking about that, and there are hundreds of millions of users who are using this. So this is a special branch of artificial intelligence, which are using a technology called what is called large language models, um, uh, uh, and this is particularly referred to as generative AI, generative pre-trained transformation. That's what GPT stands for. I'm sure that many of you have the experience of using Chat GPT for various purposes. I mean, for finding something, for exploring something, for getting some answers to this, or you can Chat GPT will also answer you. I mean, give you answers about these sites. Archaeological sites or any other thing, for example. So that's what you do there. What you are doing is you are dealing with language, you are dealing with natural language. You are asking ChatGPT a question using standard English and a natural language question. Of course, when you engage in that chat, of course, this model is trained, it is pre-trained, it is generative AI, and it is capable of delivering the answer to the question that you want. So many of you have that experience. But I'm going to tell you about this latest development, I mean, which has borrowed from the world of generative AI, generative artificial intelligence, using the same models like these large language models and generative pre-trained transformation. So you are using those models, those technologies, those platforms that have been the basis for this generative uh, uh, applications like generative systems like ChatGPT on the one hand. On the other hand, you use vast amounts of satellite imagery that have been obtained by various applications, uh, uh, various satellites and various platforms, uh, and some uh, some major applications like Google Earth, and then combining the power of those two. On the one hand, observing Earth from satellites. On the other hand, using the generative AI models that have been trained for something else, that is trained for handling text, and the same thing, and those two things can be combined, and the potential of that processing power can be used to deal with not text information but satellite imagery, pixels of satellites. Instead of dealing with words in standard ChatGPT, now we are talking about dealing with pixels of satellites, these small dots of satellite imagery for processing. And what is the outcome? The outcome can be amazing. So outcome is, some of these models can be trained to, give you some predictions, some forecasts about um, uh, various phenomena on the basis of the information that is available um, in this technologies like ChatGPT, and then by on the other hand using satellite data. For example, you can ask a question. If you have satellite imagery of one particular archaeological site that has been undergoing uh, some impacts due to uh, some effects like land subsidence or something like that. Maybe you can ask ChatGPT to predict for you what will happen if this continues for another 2 years, and what will be the scenario if this continues for another 5 years, and if there is a flooding situation, what will be the impact on this particular monument? What is the impact on this particular monument, archaeological site, in the event of a flood caused by, say, a rainfall of 100 millimeters in that area. So that is the kind of power that we are promising. So this offers unprecedented opportunities in many spheres. And I'm talking in general about SAT-GPT, not ChatGPT, the satellite, the SAT-GPT. So this offers unprecedented opportunities in many spheres, including preservation and management of cultural heritage. So cultural heritage preservation, just as much as this new technology, which is of course which has developed over the past couple of months, is capable of delivering this. And of course, if I am to deliver another talk in under this SAARC talk series in 2024, I think it'll be totally different things that we'll be talking about with the rate of technological changes. And the most striking thing about these technological changes is they are becoming cheaper and cheaper, less and less expensive. And the most important thing that we need to do as nations in the SAARC region, in such a region, in region with such rich cultural heritage, is to, uh, uh, bring in policies that will enable our institutions to adopt technology in a effective way for the effective preservation and management of those sites. And the technology is becoming less and less expensive. What is important is, having our policies in place, so that that will enable uh, institutions, that will strengthen institutions to go ahead with capacity building, technology capacity building, human resource capacity building of their personnel, their staff, and acquisition of these technologies, which are becoming less and less expensive. And then, by way of doing that, to develop the capacity of those institutions which are uh, working in the area of archaeology and our cultural heritage, uh, to harness those technologies very effectively uh, to, uh, uh, to identify, preserve, monitor, map, and finally effectively manage those cultural heritage sites in South Asian region. So with that thought, let me conclude this presentation, and I would be uh, uh, pretty happy to answer any questions that anyone in the audience might have uh, based on this presentation. Thank you very much.
Dr. Panawennage, to for such an elaborate and detailed presentation on such an important topic. Now I request the audience to ask questions, or if they have any comment or any feedback. If they have to give any comment or any questions, please.
Uh, Good afternoon, Dr. Panawennage. Thank you for a very informative lecture. First of all, I have a couple of comments and question for you. First comment is Sigiriya. Uh, Sigiriya, the western part, is the only part which has been completely explored and documented, because when you walk in from the ticket booth and the moat, when you walk towards from the western precinct in, the right side has been completely documented, not completely excavated due to lack of resources, but what is there has been identified right of the pathway which we usually take to go up, and on the left side we have identified that it's symmetrical. What is in right you usually find on the left, but detailed excavations haven't been done simply because we left it for future when there is more technology to be done. It's the northern, southern, and eastern presence which are not done. But I myself, long years ago, did a exploration from the uh, western precinct to the southern precinct, between uh, mm, the entrances between the southern gate and the western gate.
So all that work has been done by archaeologists, but as you said, more we haven't excavated, and more information can be derived before we do any excavations through the modern technology, like using various satellite images and things like that. I just wanted to clarify that point. My questions are, first one is, I know there have been some LiDAR work done in Sri Lanka. Uh, does the Arthur C. Clarke Center have the equipment and the capacity to carry out LiDAR work and training? The Department of Archaeology carried out some trainings in Sri Lanka, especially near Aukana, but I'm asking whether there is the capacity to train the archaeologists
Mhm.
in this kind of change in technology, because it's changing all the time. I just wanted to ask whether the Arthur C. Clarke Center has this capacity. And my second question is, you discuss artificial intelligence, and do we have policies in place to manage any to protect our heritage and safeguard the interests of Sri Lanka in particular, and uh, South Asia in general? Have the South Asian region established protocols and policies to safeguard the national, local, and international interests? Thank you.
Uh, thank you very much for that comment in the first place, and also for that very important questions. I would answer with the. I would begin with the first question that you asked, whether Arthur Clarke Institute is capable of carrying out such a LiDAR service and delivering such training. When it comes to training, yes, actually, we do have the expertise and we do have the capacity to provide such training in the form of a specialized training program for archaeological applications to our colleagues who are working in the uh, Department of Archaeology and various other institutions which are working in the archaeology sector. So that's perfectly possible. What we would need is a request and some lead time so that we can organize maybe uh, a training of a couple of days duration, the length depending on the exact requirements, which would be determined by looking at the training needs. So that's perfectly possible. And as for the question as to whether we can carry out such a LiDAR survey, of course, we do have our own on UAVs which are capable of you know carrying out which are capable of carrying such LiDAR payloads, but unfortunately we have not been able to procure the LiDAR sensors that we wanted because of usual problems, over the past couple of years. So we have been our spending capacity has got a little bit restricted due to obvious reasons. I would not go into the details of that, but we are in the process of acquiring that. So sometime in the future we should be able to carry it out when it is possible. Of course, we'll let all the public sector institutions in Sri Lanka know about that capacity to carry out the uh, surveys as such, because we already have our own drones. And uh, as for the training, as I said, I mean, it can be done. It's a matter of time after we get any request for such training. So those are that's the answer to the first question. And the second question is about this AI policy. Well, as for the AI policy, I'm not in a position to comment about the present status. I must say that I have not followed it very keenly over the uh, past 1 year or so. Whether there has been any development, has there been any development? Of course, I must say that I'm not aware. But I just because of that, I can't say it's not there. But I know that there was an effort some time ago. There was a committee that was established some years ago. This was about 4 years ago, to develop a national policy on artificial intelligence. And I served as a member of that committee but unfortunately, that task did not see the end. So, any later developments, of course, I'm not aware, um, not that I know. As for so in the South Asian region, of course, so artificial intelligence is a thing. This is an area where technology, technology leads. So in such areas of technology, I think even a lot of other countries have found it difficult to keep pace with the. This is a usual problem of policy making when it comes to policy making in advancing areas of technology, particularly when it comes to rapidly evolving areas of technology. It has become a huge challenge even for the countries. Um, uh, Even for the countries who are technologically advanced to keep pace with this technology. But on the other hand, it is pretty much necessary for countries like us also. I mean, we are all developing countries in the South Asian region. It is very important for us to, get on board very quickly because there is a huge advantage in using these technologies. We do not necessarily have to follow the footsteps of the other technologically advanced countries to get at where they are right now because we don't have to go through the same path. We can short circuit a lot of elements of that path, and therefore, and that is a big reason why policy making in such areas need to be given better emphasis, need to be given strong emphasis, because these are tools which uh, leverage our capability to leapfrog and come to a state without necessarily going through the same tedious path that the front running nations or technologically advanced nations have followed. So, therefore, I would say that's a very big necessity. That would be my comment. As for the comment that you made about Sigiriya, I do thank you profoundly for pointing that out. In fact, I am not an archaeologist. In fact, when I got this information from an archaeologist, he did mention it is eastern. Actually, it's my mistake that it is appearing as western flank of Sigiriya in my presentation. Thank you so much for pointing it out.
Thank you, Tina. It's not a correction.
Okay, madam.
Actually, yeah, Engineer Dr. Sanath Panawennage. Thank you for your very valuable and very comprehensive lecture. And actually, it's a very fruitful session and fruitful discussion to
Mm.
us. Thank you so much.
Yes,
Thank you.
yes, madam, I do agree with you. It was, and thank you very much, sir. It was such an information-filled presentation. Yes, one way to preserve South Asia's cultural heritage, as you have pointed out, is by utilizing space technology as a
As an enabler.
yes, as an enabler, and space technology can provide valuable tools and resources that can help in the conservation and documentation of cultural heritage. As you have rightly pointed out, satellite imagery and remote sensing methods um, can be used to create high resolution maps and the 3D models of historical sites and monuments. This can aid in the accurate documentation of their architectural features and layout. And you have also mentioned about how this virtual reality and augmented reality applications, this can also help the users to provide them with a deeper understanding of South Asia's cultural heritage. And it's also very interesting how this space based sensors can also monitor the condition of cultural heritage sites. They can detect changes in the vegetation, and if there is any change in the vegetation erosion, there is a structural damage, which can allow them for early intervention. This space enabled technologies also support the creation of digital archives and virtual museums. And this way, it can help in safeguarding cultural artifacts and making them accessible to a global audience. So I think it is important to recognize the importance of um, combining traditional conservation efforts with innovative spatial space enabled solutions, that can ensure the sustainable preservation of cultural heritage for future. So on behalf of SAARC Cultural Center, I once again extend my heartiest gratitude to you for such an enlightening lecture. Thank you very much, sir.
Thank you very much. It's a pleasure.